I have it here. Good. Hello. Thanks for being here. All right, so you are at the ChatGPT Privacy Tango, dancing with data security and large language models. My name is Jason Mancuso. This is Mike Gardner. We're from Cape Privacy. So yeah, let's get started. Yeah, so I've been working with Cape since its inception, about 5 years ago. The whole time we've been focused on enabling privacy-preserving machine learning. We've done it a few different ways. I'll talk a little bit about that. In the past, I worked on applied data science and machine learning research. And we are here at booth 411 for the future. Mike is also with Cape, so. So yeah, a little bit about Cape. We met working on open source, privacy-preserving machine learning around 5 years ago. We have a long history of contributions to open source as a result, because that's kind of how the company started. Here's some projects we've worked on in the past. PySift is probably the largest single tool that is used. It's mostly used for education, but it has been used for actual deployments. It's by a community called OpenMind. And then we're also the creators of a library called TF Encrypted. About 3 or 4 years ago, we wrote this. It's a tool for doing encrypted machine learning in TensorFlow. So yeah, Python front end uses TensorFlow for the back end. And then TensorFlow is not really secure, so it's not great for privacy-preserving machine learning. The servers themselves are kind of expected to trust each other, which is a no-go for us. So we did a complete rewrite of that in Rust for a more recent product based on multi-party computation. But since then, we've also worked with a few other technologies. We have Nitrogen, which is a open source tool just for working with Nitro enclaves, AWS Nitro enclaves. And we have Hybrid PKE, which is a Python exposure to the hybrid HPKE protocol, which is a recently standardized public key cryptography protocol, kind of one protocol to rule them all, hopefully. But yeah, that's kind of the gist of it, is that we love ML, we love privacy, we love Python, and we love open source. That's our company. That's kind of what we've been since day one. So machine learning has changed a lot in the past 5 years. This talk is about large language models, which are all the rage currently. For us, it's a big departure from where our company came from. So we've kind of had to get our heads around it fairly quickly, I think, just like everybody else. So just an overview of the talk is that we'll talk a little bit about large language models, what they are, how they relate to data privacy. Can you even have data privacy in a world where large language models are the main form of machine learning that gets done? Talk a bit about this idea of the privacy tango, this metaphor, and also discuss some privacy primitives to prepare us to talk about one way that we've tried to solve this kind of paradox. And then we'll go with a demo of that system, talk about how we designed it, analyze if it's actually preserving privacy and if it still maintains utility, and then talk about some alternatives, conclude, and yeah. And hopefully we'll have time to have Q&A if there's any questions or conversation to have. So, what are large language models? Essentially what they are is just a giant model trained on internet scale data, an internet scale data set, where it's a language model. Given some input or previous tokens in a phrase, let's say, predict the next token. And you just do this on a massive scale. Tokens themselves it's kind of an overloaded term. They could be letters, morphemes, or full words. Most recently, I think it's kind of like, it's not really morphemes, but it's just pairs of letters. And so yeah, the main feature why we call them large is because obviously they're very big. In the context of machine learning, in the past maybe we've had million parameter models. Now these things are billions to hundreds of billions of parameters large, which means normally they can't actually fit on one computer for inference unless you do some real clever hacks and stuff like that. So that's one reason they're large. Another reason they're large is because of the scale of data they're trained on, which is generally internet scale. It's not necessarily all public data, although a lot of the open source models are trained on just public data. I think OpenAI, at least, has admitted that they've use data partnerships and stuff like that to get higher quality data. So that's one aspect that's also large, is the amount of data they're trained on. But really the interesting thing about them is that at that scale, these models show emergent behavior that's useful for like a lot of different tasks. That's actually kind of always been the case for language models. I have two papers here cited that are from 2017 and 2018, kind of before anyone was talking about LLMs, but like when I read this paper in 2017, I remember thinking, that is crazy. This is a paper basically saying that a language model just trained on a large data set of Amazon reviews. One of the neurons in its representation ended up being a state-of-the-art sentiment analysis detector. It was better than all models trained specifically for sentiment analysis, but it was just one neuron that it had found in its internal representation. And its job was just to predict the next token, just like this. So this was like an early precursor saying language models are useful for a variety of other tasks. The next year, Jeremy Howard, who's a big open source ML guy, him and Sebastian Reuter published this paper talking about how actually it's not just sentiment analysis, basically all these other text classification problems can be solved, or maybe not solved, but you can get state-of-the-art performance just by pre-training a pretty good language model and then fine-tuning for whatever task you want. So this is kind of like the beginnings of it. And now with GPT-3, et cetera, we find out that actually if you just go big enough, you don't even need to do the fine-tuning. You can just fit whatever you want into the prompt, and as long as you structure the problem that you care about in the prompt well enough, generally language models can get smart enough to just do the task for you. Obviously, there's some caveats there, but and yeah, so some general modern examples of language models are below. Hopefully, you've heard of one, if not several of these, because I mean, essentially, it's OpenAI's, it's Google's, and then it's it's Facebook's, which is now kind of open source, and then it's all the open source versions that have been trained as a result. ChatGPT, I'm sure everyone's heard of this. It's just it's probably the most famous large language model because it actually hit the mainstream and people are using it in their everyday lives, at least people that I know. What it is really is just a large language model and then fine-tuned with human feedback, human interaction, using a technique that was published by OpenAI a while ago called reinforcement learning with human preferences. And then they fine-tune it, not just for safety reasons, so that like the language is kind of, I mean, okay, that's one reason that it gets fine-tuned is to prevent it from spitting out things that you may not want it to say, because obviously internet scale data is going to include a lot of stuff that you don't necessarily want in your chatbot, but also to just actually make it so that you can have a conversation with it as opposed to provide it like the first half of the sentence that you want it to complete, right? Previous language models, like you actually had to figure out how to start the text that you wanted and then have the model fill it in. The fine-tuning actually allows you to like interact with it as if it's another person you're having a conversation. But the jury's kind of out if that's the best way to use these things, but that's kind of the way that OpenAI and then as a result everyone else has kind of done it. So there are a number of privacy concerns when we think about large language models. The first and most basic is that there's the question of how do you handle sensitive information when you actually want to solve a task that requires that sensitive information. This could be PII, like health information, or just generally like sensitive personal information about yourself or other people. It could be confidential business data. It could be trade secrets, stuff like this. These are the things that you don't necessarily want to just give to OpenAI so that they can run it through the language model, because you don't really know. I mean, we can all take OpenAI's word that they're deleting data after 30 days and they're not using your data for retraining, but we can't really know unless they were to implement some mechanism that would prove that to us, and they haven't yet. And so you have this risk of leaks from those large language providers like OpenAI or Cohere or whoever else. You have data leakage risks outside of that, so this is more about the training data, where the large language models, they see so much data, they actually memorize a lot of it. And if you really get detailed with your prompt engineering, you can actually extract that training data from the model pretty easily. This is true of other machine learning models. It just seems to be the fact that the scale of these models makes it actually kind of more of a concern because it's been trained on massive amount of both private and public data. And then There's a kind of another privacy issue, which I'm not even sure if it's a privacy issue, but I included it here. It's this idea of hallucinations about individuals. The fact that it has any knowledge of individuals means and that paired with the idea, or paired with the fact that these language models tend to hallucinate if you kind of lead them into the hallucination, it's kind of a bad recipe, right? Where you have maybe lesser known people where it's seen the name, it's seen some things about them, it knows enough to sound smart about the person, and then you hallucinate, or you lead it into a hallucination, and it just spits out garbage about that person that's not actually true. That is definitely possible. And I would say that's kind of a privacy concern, right? Because like your data or information might be in this model, it might think it knows about you and then say something that's false, and you know, I would say that's a risk. And then obviously there's some data that can only be used in very constrained ways. Data that's covered by GDPR, CCPA, HIPAA, et cetera. There's a lot of laws like this around data usage, so you have to consider that whenever you use any data with, or whenever you move any data outside of any organization or even within an organization. Like these are things you have to consider. And most businesses have practices for dealing with this internally, right? So these are the two, I think, that are most relevant for this talk. Data leakage risks and hallucinations. I think of these as more of like operator problems or provider problems where OpenAI better be figuring this out, Cohere better be figuring this out. But like as an app developer, there's not much I can do about these. There's much more I can do about the first and the last, or at least I would hope so. But that's actually the question of this talk is like, well, I'll say that, is there any way for us to use these large language models without exposing all of our sensitive data to large language model providers? And we use this, actually GPT came up with this metaphor basically when I was talking to it about this talk. It was saying, why don't you use a dance because, I mean, I guess one way to think of it is a tango is hard to do, and it's apparently also hard not to feed sensitive data to ChatGPT based on all these headlines where people are, due to some errors on OpenAI's part, ChatGPT actually leaked some sensitive information, including some Samsung source code. Sam Altman, the CEO of OpenAI, is there apologizing for that, and then you see in response a bunch of organizations basically saying, oh, that's it, no ChatGPT for us. We're going to cut that off right now, which is sensible, I think. But I mean, I don't think that has to be the end of the story. Because really, I think like we can describe this situation as kind of a dance between privacy and utility. If you have full privacy, you can't really use these models the way they are because you can't actually send sensitive data to them. I mean, okay, one option, which I'll talk briefly about, is self-deploying an LLM. It's hard because these models are very big, they don't fit on a machine, and actually operational, like standing it up and being able to hit it with requests is one thing, but actually operationalizing it, maintaining it, et cetera, completely other thing. I'll also say that the reason that it's so cheap from OpenAI or Cohere is because of economies of scale, and when you're self-deploying, you don't get that, so it's always going to be more expensive no matter what. Even if you do have the expertise and the budget, you're still always arguing with that price gap. And I mean, so that's like one, and also the open source models, the models that are available to us are just not as good as the ones that are being developed by these LLM providers, right? GPT-4 is generally used to evaluate open source models against GPT-3, meaning GPT-4 is like if GPT-4 can evaluate that, obviously it's clearly much stronger than any of these individual models. And so as a result, you're kind of going to lose utility no matter what by not using an LLM provider. And the fact that you gain on privacy, let's say it's perfectly private because it's within your organization, it's kind of along with your compliance constraints, et cetera, in your organization, you're never going to reach that same level of utility. And obviously the cost factors into utility as well. It's not just efficacy, it's also cost. And so you kind of have like complete privacy and like half utility, or like no privacy and 100% utility by going to an LLM provider. And the question is, can you do something in between there? And having worked on privacy for a while, I would say yes, we can. The other reason that I actually thought this metaphor was interesting was because, to me at least, when you build systems that can solve for both this data privacy problem and without sacrificing utility, to me these are always very elegant solutions. Or it feels pretty elegant once you see it in action and you pull it off, knowing that the data is private. So that's why I thought the metaphor was cool. When it spit it back out to me, I was like, all right, I'm gonna go with this. But before we can actually talk about like how we would build a system like that, we have to talk about some of the primitives that are available to us to build privacy-preserving technology. So the first one I'll talk about is confidential computing. This is kind of like an industry buzzword, but like the real core technology is called the secure enclave. The idea of it is it's just an isolated and hardened, constrained computing environment where you run security-critical applications. Your phone has this if you own an iPhone. It's where they keep all of your biometric data. That biometric data can never leave the enclave, and they take it very seriously what services and programs can actually interact with any data that's in the enclave. It's basically as close to a black box as a computer can get while still being somewhat useful. And the main feature of it that protects it is that the enclave has a separate CPU and memory from the host machine. And it's there are very strict rules about how the host machine can interact with that CPU and memory. One main feature of enclaves that allows you to use them securely is this idea of attestation. Essentially what it does is it allows enclaves to verify themselves and the code they're running to someone interacting with it from the outside world. So as a client, you can kind of make an attestation request to an enclave. The enclave can say, here are all the boot statistics and measurements that I made as soon as I booted, as well as kind of like, let's say, a hash of the entire chain of software that enabled me to run some application code. And here's also a hash for the application code itself. So you can know, A, that the device has not been tampered with at all, and then B, that you're running a particular application inside this box, so that you, at least if you know what that application is ahead of time, you can be reasonably sure that there are no other pieces of code in there that are splitting data off, shooting it somewhere else, et cetera. If you know the functionality of the application, then you can, after you've attested, you can be sure that any data you send in is only going to be used according to however that app has been developed. And one thing that you can get with these two primitives is you can have, you could set this up to do more complicated services architecture, like microservices. You can have several services and enclaves that can only talk to each other, and they can be sure that they're talking to the right service. And as long as each service has like a clear definition, you can do stuff that way. You can also do distributed computing where they're all running the same program, and you're just trying to, scale out and do stuff that way. So yeah, it's kind of like a building block to incorporate security critical code into your larger applications or ecosystem or whatever. So that's the first primitive. The second primitive is PII removal and text de-identification. This is basically just removing sensitive information from natural language documents. For example, names, places, organizations. There are a lot of other categories of text that you would consider private. Some of these can even be linked all the way up to HIPAA or GDPR requirements. But there's essentially like if you have a list of things that you wanted to classify, you can train a machine learning model to identify those categories and redact the terms in the document. Yeah, essentially what you do is it's named entity recognition, and then you do a masking step to redact the data. And so that's an example of what it looks like after you've redacted data. Obviously, there's problems with this, right? Usually it's based on machine learning, which means that there's always going to be some error bar, whether it's 10%, 1%, or 0.1%. Like the errors still matter, and you need to plan for those. But and the other idea is that this might remove sensitive terms and PII, but not all. Let me think about this. Redaction is not equivalent to privacy, right? You can have concepts be discussed in very plain language without sensitive terms, but still be leaking that concept through after the text has been redacted, right? So it's not a perfect definition of privacy, but it is what it is. It's for a lot of businesses, this has been good enough in terms of privacy, but for some, it's not. So that's something to keep in mind. Okay, so I've talked about these primitives, and I wanted to talk a bit about how we built a system to try to take advantage of LLM providers like OpenAI while trying to give back some privacy. So it's not this 100 privacy, 0 utility, or 100 privacy, 50 utility versus 0 privacy, 100 utility trade-off. Try to get some maybe better numbers in there for us to work with. So did you want to discuss this stuff?
You're doing great.
All right.
Just kidding. Okay, so I'd like to show you a demo of what Jason's talking about. And so this came about through the popularity of LLMs, OpenAI in particular, and in the context of finding utility in a business environment, a company came to us and said, listen, we think this could be transformative, but the business we're in, there's a lot of sensitive data, proprietary data. So to set the stage here, that's what we're dealing with here. Let's say you own a business or a startup, and the customers you work with have information that they'd like to leverage OpenAI or a public LLM for. But of course, you don't want to send that out, right? We heard about Samsung already. So that's the setup here. The idea of what we'll see here, in order to answer questions, though, you need that context. So we will upload information that's sensitive, and then we'll ask some questions. And the idea is that we'll get answers. So nothing special except for everything Jason said, which is we'll do the redaction, we'll cleanse the data in a way that we can still use OpenAI and get that back. So we'll show you what that looks like, and then Jason will continue to go under the covers with how that's happening. So 2 things to point out here. I mentioned them, the documents and the user queries both potentially have sensitive information, so we want to redact both. And of course, we don't want to send any of that to the LLM. So those are the kind of 2 challenges that we'll make sure we're addressing. Real quickly, this is a picture of what I just said. And to start from the left here, we're going to start with a question. And the question involves information that is sensitive or particular to our customers. That information is going to be encrypted so that even the cloud provider or CAPE can't see that. Once it's redacted, we're going to send it out to ChatGPT. So the question, along with that uploaded information, the additional context, are going to be sent across redacted. We're going to leverage the capabilities of the LLM to get an answer back relative to the redacted versions. Then we're going to re-identify the things that we de-identified so that the response is going to be useful to the caller. And that as well is going to be encrypted on the way out, as well as sent over TLS. So this is sort of the system. Let's take a look. There we go. Okay, we have a chatbot here. Let's, well, actually I have a question first before we jump into this. We're at PyCon. Does anyone know who the creator of the Python language is? Or Guido? Anyone else? Okay, I was going to use Guido, but I think it's actually Dutch. Guido might be more appropriate. So I'll use Guido. No one had anything any better, and thanks for not making me use the accent. Guido, so let's use that as an example. That's our sensitive information. Let's pretend that's data security information, how many, how we protect our web servers, or who your clients are, financial information. It could be anything, but for fun, we'll use Guido. So the first thing that we'll do here is provide some context. Guido van Rossum. So I'm uploading information, and this could be PDFs, it could be sensitive financial documentation, et cetera, whatever it is appropriate for the use case, but we're uploading this additional sensitive information. For those that understand what's going on, I'm going to change my index for the... Oh, I should have done that first. Sorry. Did that in the wrong order. I changed my index and then after I uploaded my data, so we have to re-upload so that we actually have it in our vector database. Okay, so that's done. Again, hand waving a little bit in the demo, but Jason's going to go through step by step. But the point here is that we've uploaded some sensitive information. Under the covers, it was encrypted and sent across. Now let's ask some questions here. We'll start with, where does Hito currently live? And this could be, let's say you're going for compliant. Oh, got a question. Yep.
Zoom in. Maybe.
We got to do over here first. Better? Okay. So again, we're using Hito and some information about him, but maybe we're doing a question and answer about some regulatory compliance, PCI or something, and we've uploaded a bunch of policy docs, knowledge-based information from a customer, and now you can interrogate if you're meeting the policies or that are required for certification. But again, we're just using Hito for fun, and we asked a question, and it looks like we got an answer. That's great, because that's what we expect. The idea is that it was privacy preserved, and we'll talk about that in just a second. But let's just ask it a couple more questions for fun. If you don't know this, Hito worked for Dropbox. So we'll ask when. So the power is not in these questions and answers, of course. It's that we can leverage OpenAI's LLM for getting us good answers, and it looks like it's working. So fantastic. I'm going to stop there because you get the point. We could continue to ask questions about whatever context we provided through the upload, and now we're, in essence, using ChatGPT, just like you would with information that's not sensitive, but now you can, with proprietary or sensitive information. Yes?
Why did it assume that we are talking about Hito when also we didn't say the full name? There's so many other same first name.
Yeah, we provided context through the uploaded document, which has Hito, and so it's going to over-index toward that. Go ahead, Jason.
We basically just fed it his Wikipedia page. So it has essentially all these sentences about his life in context with his name. Now what's interesting is actually this is what the model sees. This is what we pass to them. We don't actually, question. That's a good question. I actually haven't tried that, so I think it might. Oh, actually, no, it would not work. It would actually just say, sorry, I don't have the right context. I mean, if you really want, I can. When did Gary work for Dropbox? Yeah, I think it'll basically just error. It'll just say, like, there's not enough information in this context to answer the question. I hope. Oh, no. So do you want a job?
No more questions.
Yeah, don't forget that. Okay, so.
Just joking, by the way, if you have questions.
Yeah. So, yeah, obviously, like this is very new for us. We've built machine learning tooling for a long time, but like using a machine learning model provider is pretty alien to us because that's always been like very counterintuitive for us in terms of privacy. But I think the economic argument, or just at least for now, LLMs are kind of stuck in these providers. So unless they get cheaper to deploy significantly, or the technology just becomes more widely available, I think this is one of the best solutions that we've come up with outside of deploying for yourself. Anyways. I wanted to dive in a little bit about how the system is designed, because I think there's some interesting things about how we do this. I mean, our two goals here are A, that OpenAI doesn't see sensitive information, but also B, because we're deploying this ourselves, we also don't want to ever be able to see anybody's sensitive data. So essentially, we want not only a secure channel from the client to OpenAI, where we can't snoop on any of the intermediate results, or intermediate values. We want it not only to be a secure channel, but also to be like a redacted channel as well, where the text gets redacted on the way, while also still giving relevant context. And we do this through essentially this is kind of simplified, but for the diagram it works. essentially 3 services. So the way we make sure that this is all secure is we first start with the setup phase. 2 things are happening here. One is that, I should say, we have 3 services: database service, which is kind of a normal just database layer, which includes a vector store database. A server, which is just like your general fast API, like web server. However, it's inside of an enclave, so you have some additional like authentication abilities with that, like that attestation I was talking about. And then we have a de-identification service. This is another server running a machine learning model, waiting for prediction requests. It's also running in an enclave. What this allows is for these 2 enclaves to do mutual attestation, meaning that they know each other more or less, and that data between them can be sent while knowing that nobody's going to be able to snoop on that data just based on, because they both know that they're enclaves and they both know that all of the software is in expected bounds, I guess. And yeah, so the client can, what this allows is essentially any data that the client sends, the client can be sure that the server is not going to leak that data to anybody else except for the de-identification service. But because those are mutually attested, you can essentially assume that the client has attested to the 3rd service as well. So the client can know that as long as data is moving through those 2 services, it's in a box, nobody can touch it. So this setup phase is just doing that mutual attestation, and then the client attesting to the server. As part of that, they get a public key, which they're going to use to encrypt their data. So this is an example of a client uploading data to the knowledge base. They want to save this document, they encrypt it, they send it to the server. The server, actually, before it does anything, it's going to decrypt this data. It's in a black box, remember, so we can still kind of consider this to be encrypted. It's going to decrypt it. It's going to create embeddings. Then it's going to take that document and the embedding, re-encrypt it, and then insert it into the database service. So at this point, this is a normal database because all of the data inside of it is essentially AES encrypted, and the only instance or service with that key is going to be the server. So the only way that this data is ever useful to anyone is if this server inside of an enclave pulls it back, it has the AES key and decrypt it only inside the enclave. So this kind of just gives you some external storage to work with. In theory, we could put this in the server as well, but in practice, it's just easier to do this, I would say. So let's say we've uploaded a few documents. They're all encrypted in that database service. Now that's how we populate the knowledge base. How do we actually satisfy a user query? For example, let's say that this is some data about your user base, and you want to ask how many of your users are being billed through Stripe. First thing you do is encrypt that prompt, that request, send it to the server. It gets decrypted, and then using the vector store in this database service, you're able to essentially get relevant documents from the knowledge base, because you have, essentially what you do is you embed the prompt. In this database is a bunch of documents with their embeddings. You do some math between those embeddings. By embedding, I mean it's essentially just another term for like a dense vector that semantically represents the text that you are talking about. And so you can do like operations with those embeddings, like you can add them together and it preserves like the semantic of like this plus this, or you can subtract and say I want like, let's say a zebra without stripes and you get a horse, for example. That's what an embedding is. And so, but it allows you to just like operate in the context of just like dense vectors instead of discrete text space. Yep.
I don't know if this is the right type of questions, but I'm curious to know if there's any risk of like if there's any risk of like embeddings being kind of reverse engineered to be like kind of unredacted, rather like if you will, like if you're kind of taking these sensitive values and generating embeddings from those, is there any risk of those being like leaked in their embedding form and then someone being able to say, oh, I have this random embedding value and I can turn it back into like what it originally was?
So if let's say the attacker got access to the embedding, but not the raw text, and they also had access to the model that was used to generate the embedding, then yeah, they definitely could do that. For this system at least, anything in these like boxes is considered kind of secure. So if they were to get these embeddings, we'd have a bigger problem than that, I think. But yeah, in general, embeddings are reversible. Well, I guess it depends on how you do the embedding, but that's a little bit beyond the scope of this, I think. At least for us, like, so for example, you can use OpenAI or Cohere to generate embeddings as well, but you have to send the text to them. So for us, we use like our own model inside of the server to do the embedding. And with the vector database, you can still use, because you can use your own embeddings with a vector database, do all this context retrieval stuff, and then we're good to go. That's how we do this. And what we have here at the end of it is a prompt, relevant documents, a query, user query, relevant documents. We stuff them together, that forms the prompt that we want to send to OpenAI. However, the sensitive information could still be in this prompt. So this is the part where we do the actual redaction. We send it to our model, it does the redaction. For example, here, Stripe was redacted out in the prompt. You could also imagine in the document there's a bunch of sensitive terms that would also be redacted. The reason we do all of this at once, the documents haven't been redacted yet, the prompt hasn't been redacted, is because we want the redaction to be consistent across documents and prompts, right? And if we were to do all the redaction up front on the documents, we wouldn't necessarily be able to recognize sensitive terms in queries the same way. But yeah, once that's been done, it can go back to the main server. And at this point, we can actually send it to OpenAI because it's been, in theory, redacted. We get some answer back. For example, 10,000 users are billed by organization. And because the server, so as part of this de-identification service, you also get back a kind of the mapping that you use to do the redaction. So it'll just show, like, let's say, in this case, organization is mapped to Stripe. So when you get the response back from the LLM, it should be referencing this organization mask, and then we can undo that mask with the mapping that we saved from the de-identification service to say, okay, it's Stripe in the response. And at that point, we're ready to return it back to the user, and we do that over TLS. So the idea here is that the data, any sensitive data that the user supplies is always locked to the point where we cannot see it as CAPE. We're just acting as an operator for these services. And we're kind of acting as like a de-identifying proxy between them and OpenAI or any other LLM provider. This is not specific to OpenAI at all. It could be Cohere, or I actually don't know if there are any others besides those two. Those are the only ones I know about. Okay, so what's cool about this, in my opinion, is we, the service provider, can host the system without deploying an entire LLM, as long as those secure enclaves are accessible. There's definitely a learning curve when it comes to working with these enclaves, but it's not so bad that we can't do it. It's also a lot cheaper than hosting your own LLM. Yeah, the fact that these documents and prompts get end-to-end encrypted so that we never see it, I think is pretty good. I would say that's a plus from the zero privacy we had to, like, I don't know, 60, 70, 80, let's say, hopefully. I mean, in practice, the de-identification model that we use is actually very, very accurate. It's above 99% accurate. So there will be a small number of cases where we miss and we actually feed data. Like, there will be a sensitive term in there that wasn't caught, but for the most part, we get a lot of them. And yeah, I would say this improves the privacy of the overall system. However, so the question, I guess, that remains is like, and the LLM providers can still be used for their economies of scale, which is kind of the nice thing about this, is that you get a lot of cost benefit. Yes?
How would you say that the success rate in terms of filtering sensitive data compares to what a human can do? I mean, because people miss sensitive terms in documents as well. So do you have any data that shows? I'm just curious.
Yeah. We don't have data on it because we have yet to do a full comprehensive evaluation. I think, and also in the context of LLMs, evaluation is really hard. I think it's an open question how you evaluate those. I will say that for that model, we're using something that's as close to the state of the art as we could find, or that we could build, or that we could, yeah, just use. And I'm not sure how it compares to humans. I would have to look into that. But yeah, so these are all the benefits. I think it's, you had a question?
Yeah, so is it useful to use language model to do the redaction, to catch things like idioms? So for example, CBS News got, they said in the dispatch, we were taken for a ride in the context of doing journalism on the Soviet Union. And that slid right past the censors. So, I mean, are you looking to redact, information that's sensitive in a very subtle way?
So the LLM isn't actually being used for redaction at all. It's a separate model that does that. You could fine-tune an LLM to do that. We have not had a chance to do that, but that would be possible. And it's possible that you could improve the efficacy of the model that way. I think like idioms, yeah. Maybe another example of this is like if you were, let's say, redacting information about Warren Buffett, and I think he has a nickname. I don't remember what it is, but it's like the something of something. I don't know. Do you know?
Oracle of
Yes, thank you. So like if you were to pass this through the redaction system, it would probably say like Warren Buffett, and that would be redacted, and then it would be like Oracle of Omaha, and it'd be like Oracle of Location. But then you're like, okay, who? That would probably be a failure on our part, even though like the model worked the way it was supposed to. So yeah, I think like ultimately rewriting text to remove sensitive information is probably a better way of doing this. But yeah, we haven't tried it, so yes.
Yeah, I guess I was just curious, though, if I understand at the beginning, you're saying the model's basically trained to like predict the next word or kind of like a skip track thing, then your redactions are like the skip that it's trying to predict in a way. Is it not like easy for them to take the documentation context that you provided and basically use the model to predict what would have been in this spot that says what we're saying? Because that's how it's kind of trained, I'm thinking.
Yeah, that's an interesting idea because I'm sure that like for example GPT-4, if you gave it that Oracle of Omaha example, it might be able to actually unredact the text on its own. Yeah, that's another kind of attack vector that I hadn't thought of. Yeah.
Have you run an evaluation of like, if you have, it sounds silly that you ask ChatGPT to unredact text, how successful it is at doing that, or like common documents that you keep?
I have not, but honestly, that is like probably the next thing I'm going to do like next week. So, thanks. Sure.
How does Kate never see the data if they decrypt it and then do the attestations? Are they seeing the data in order to do the?
So we are not while we can operate the enclaves, the idea of an enclave is that the operator can't see what's inside of it. That's like the whole reason it exists. Technically the security model is the host instance. The host instance cannot look at anything inside of the enclave. Here in the diagrams, I have these bars, which is kind of meant to say like the outer square is the host instance and like the inner square is the enclave. And really we don't use the host instance for anything except as a proxy. So when you send a request to the server, technically you're sending a request to a proxy. That request is encrypted, so it can't snoop on the data. Once it makes its way into the enclave, that's when you're free to decrypt it, because when you're inside that enclave, the host can't actually access it. Because the CPU memory are isolated, the CPU and memory of the host machine doesn't have access to that memory or that CPU processing. So yeah, that's how you generally that's how enclaves work. So I mean, the real question for enclaves is like, how strong is that separation? Like, yeah, you can say it's like air gapped, but that doesn't necessarily mean that it's perfectly secure. In fact, enclaves in the past have been broken. However, the cost of pulling off an attack like that is extremely high. So yeah, there's that whole end of it as well. But I mean, I would say as long as you're not worried about like nation state level actors hacking these systems, it's generally a pretty secure way of processing in an encrypted fashion. There are other techniques for doing this. Actually, I was going to go to the disadvantages section and talk about some of this stuff. Oh, maybe it's the next section. Well, anyways, there are other technologies. Homomorphic encryption is one. Multi-party computation is another. These are more software-based, cryptographic approaches. That, yeah, you can say that they have different trade-offs, different levels of security, different performance levels, and with enclaves you can just run any software in them, whereas with each of those you have to rewrite the software from scratch in a compiler or a framework that allows you to use those tools. That's what we worked on at the company for the first several years, so I'm happy to talk about that after. So we talked about the benefits. I would say here's some disadvantages of the system as we see them. So one issue that we found is that our de-identification model, while it's good at what it does, it lacks more context. So it will not do entity co-reference resolution, which is an NLP term for, I can't recognize that Warren Edward Buffett and Warren and Buffett and Warren Buffett are all the same person. So this is an NLP problem, which is like almost as hard as any other NLP problem, maybe except for language modeling, but it is a hard one to solve. We have some basic ideas how we do this, but in general, I think it's like you could argue that you need an LLM to do this step for you as well, right? Which is kind of like a chicken and egg situation. I don't think so completely. I think there are solutions here that are much easier, but I will say it's not a very one-step solution. And then yeah, the two things I mentioned before, which is that accuracy, even though it's above 99%, is still a problem. You still have to plan for the fact that you're going to have errors here, and customers have to know that and opt into that. And then de-identification isn't equivalent to privacy. So yeah, differential privacy is the best formal way we have of describing privacy, but it's not clear how that would fit into this kind of a system at all. So that's that. Some alternatives we considered are, I mentioned homomorphic encryption and multi-party computation. These are two other technologies for doing secure processing of data. Like I said, enclaves are the fastest, most general purpose, and most cost-effective solution for this problem, which is why we use them. So actually, another kind of fun fact is that the NVIDIA H100, which is what OpenAI trains GPT-4 on and what they use for inference as well, likely, no one really knows, but they are actually able to do confidential computing on their own. They have enclaves as part of their offering, and I'm guessing that OpenAI takes advantage of that. The fact is that they haven't actually exposed any of that functionality to users, though, which still means that there's this issue of how can we trust OpenAI that they're keeping data secure? Like, yeah, sure, when they're, because I mean, from their perspective, what's probably most valuable to protect is the model itself. So yeah, they may do inference in an enclave, but the data up until the point where it hits the model is probably still in kind of normal servers. So I'm sure they have access to that data. I mean, they definitely would because they want to be able to improve on their mistakes, right? But yeah, I mean, this is all just guesswork because we don't really know what the provider's ever doing. But yeah, it would be much more straightforward if they just exposed some of those features to us. That way we wouldn't even have to be there. We could just use those features of the LLM and build cool stuff on top of it. And yeah, in the future, this kind of system might not be necessary as well because of the cost issue might not be as strong as it is today. Although the economies of scale argument, I think, always will apply. So yeah, that's it. Maybe as a quick recap. Currently, data privacy prevents enterprises from using LLM providers. Self-deploying LLMs can solve this, but there are other issues there. Primitives for private and secure computing can be used to improve this trade-off, along with a lot of other cool things, honestly. Like, this is one application, but we have done a lot of other cool things with these privacy-preserving technologies. And hopefully you learned about it today and are interested as well. But yeah, if you're interested in any other applications of this kind of technology or if you want to play with the demo a little bit, we'll be at booth 411, so please come say hi. Happy to talk more about this stuff there. Or now, if we have some time. Yeah, so thanks.